This is a word problem from the 2x2 systems quiz. Again, this is in Unit 4, so we're going to be using systems of equations to solve this. That means two equations and two unknowns. So let's jump into the problem. Mark left his mountain retreat at noon and headed for the sea. Lola left the sea at 1 p.m. and headed for Mark's mountain retreat. It is a well-known fact that it is 370 miles from Mark's mountain retreat to the sea. If Mark and Lola meet at 3 p.m. and the sum of their speeds is 140 miles per hour, what is Lola's speed? Okay, so this sounds like a rate times time equals distance problem. That's the first thing to think of. I'm also going to be calling our variables m and l instead of maybe x and y, just because Mark and Lola. And furthermore, we're asking for Lola's speed. So if m and l are variables, l will be Lola's speed and m will be Mark's speed. And that's good to know because rate times time equals distance. And we're dealing with rates, times, and distances, so that should work out well. So let's just call L Lola's speed for now, and we'll see how that plays out. Again, this is a little confusing. They meet at 3 p.m., right? So I'm assuming that's in the middle somewhere. Maybe not quite the middle, but somewhere in between the sea and the Mark's mountain retreat. That's just what it sounds like. That's my best guess, and I'm pretty sure that's right. So why don't you draw out a picture, right? I think this is the best way to do it. So I started drawing out the picture, and we'll fill this in a little bit. But I just wrote Lola at the sea here, and Mark at his mountain here, right? So how far apart are they? Well, it is a well-known fact that it is 370 miles from Mark's mountain retreat to the sea. So I'm going to fill that in. 370 miles. Just make a picture. You can really do it any way you want. And just make sure to label, get all this information into the picture. I think that's what helps me the most. So, okay, let's keep trying this. So what else do we know? Lola left the sea at 1 p.m. and headed for Mark's mountain retreat. Mark left his mountain retreat at noon and headed for the sea. Lola left the sea at 1 and is headed for Mark's mountain retreat. So if Lola left the sea at 1 and they meet at 3, that's 2 hours. And Mark left at noon and meets at 3, that's 3 hours. So Mark's going for 3 hours. I'm going to write that here. 3 hours. And Lola's going for 2 hours, right? She left at 1, he left at noon. So when they meet, it will have been in the middle somewhere. Mark will have been traveling for 3 hours, Lola for 2. So I hope this starts to help you. Because what we're going to see now, again, we sit and also write down our variables. What did we say for our variables? So we said L is Lola's speed and M is that right? Yeah, what is Lola's speed? M is Mark's speed. So again, write down all the information you have. And so you can see that rate times time equals distance. So whatever this distance is, it can be expressed as 3m, right? Rate, which is m, times time, 3 hours, is distance. So this is the entire distance. This is the portion of the 370 miles he's traveled. And 2 times L, right? Rate times time equals distance. That's the distance Lola has traveled. So you can see here that 370 is the same as the sum of 3m and 2l, right? Rate times time equals distance. So his distance plus her distance is 370 miles. So we've got an equation there. So that's 370, or let's do, what did we just say? 3m plus 2l equals 370. Okay, so that's one equation, right? What other equations can we write? So let's reread this. So is well-known fact that okay, here's another piece of information. If Mark and Lola meet at 3 p.m. and the sum of their speeds is 140 miles per hour, what is Lola's speed? Well, again, let's look at what we wrote down here. We did L is Lola's speed and M is Mark's speed. So if the sum of their speeds is 140 miles per hour, well then L plus M equals 140. L plus M equals 140. And if and I don't want to confuse you here, but so these are rates, and the sum of the rates is 140, but it can also be 1 hour times miles per hour, and that gets you miles. So these can both be in miles, essentially. If you put a 1 hour in front of each one, they'll have both gone for 140 miles, right? If the sum of their speeds is this, after 1 hour, that's what they should have gone. Okay, so we have two equations and two unknowns. And actually, this equation doesn't have any coefficients, so that should be pretty easy. We can just say, if we want to solve for L, why don't we just say M equals 140 minus L? And then let's plug it into the top one. So we'd get 3 times 140 minus L plus 2L equals 370. Okay, let's distribute. So that's 3 times 140, well, that's 300, plus 3 times 40 is 120. So that's 420. Again, I did that in my head, but that's bad habit. So I'm going ahead and check 3 times 140, 420. Perfect. Okay, and then 3 times L is 3. So that's 420 minus 3L plus 2L equals 370. Okay, and now combine like terms. So we'll get negative L here. So 420 minus L equals 370. Let's, I would add L to this side to get it positive and then subtract 370 from 420. So let's kind of swap those around. So 420 minus, oh, sorry, this is cut off the screen. 420 minus 370 equals L. And again, you can do that in your head. I see that it's 30 to 400 plus 20. That's going to be 50, but it's bad practice for me to do it in my head. 420 minus 370 equals 50. So 50 equals L. And that's what we were solving for, Lola's speed. And we just called that L. So let's show the answer, 50. And that's exactly what we got. And please feel free to email me or call me or ask any more questions if you're still confused in this.